Welcome back to LocalM Tuts. I'm Nilay Parikh. This is lesson 3 of 16, A2A Architectural Deep Dive. Last time we explored why A2A exists and the 5 design values, where it fits in the agent stack. If you're watching this as a standalone video, and find the complete course in the playlist below. If you are eager to jump straight to the code, hands-on lessons start in lesson 5. But this architecture session is especially important. Agent card, the task take machine, SSE streaming are the concepts you will implement directly in the coding lessons. Understanding them here will save you time when you're writing the code. A2A is organized in 3 layers. At the bottom, the data model, defined in protocol buffers, is a canonical source. Above that, the abstract operations such as like send message, get task, on top protocol binding. The concrete wireframes. The spec currently defines 3 protocol bindings: JSON-RPC 2.0 over HTTP, gRPC, and HTTP plus with JSON REST. In this course, every server you will build use JSON-RPC, which is the most common binding in the ecosystem. So let us start with cornerstone of discovery, the agent card. Every A2A server publishes the JSON document and the well-known path, which is /well-known/agent-card.json. The agent card has 3 main sections. First, identity, such as name, description, version, URL. The second, supported interfaces. An array of interface objects, such as carrying URL, protocol binding, protocol version. The third, capabilities, booleans, an array describing what agent can do. Streaming support, push notification, extension, etc. And the skill with ID, name, description, tag, example prompts, input models, and output moves. Now, messages and parts. When a client works to an agent, it sends message. Every message has a role, either it's a user or agent. And every array of part, a part is one of the type: text, raw byte, URL reference, structured data. Each part can carry metadata. A file name, media type, extra, key value pairs. This means you can send plain text, upload a CSV file, reference a cloud storage URL, or pass a JSON schema, all in the same message. The task is the central coordination object. When you call send message, the server creates the task with unique ID. The task moves through the state: submitted, working, completed, failed, cancelled, or so on. The RC 1.0 specs adds 2 new states: input required, where the agent pauses to ask user for more information, and the auth required, where the agent needs additional authentication from the client. Let us look at this state machine on the screen. The mermaid diagram shows all the transitions. If you notice, the input required and auth required are looped back to working. The terminal state are complete, failed, or cancelled. When the task complete, it produces an artifact. An artifact generally has an ID, a name, an array of part for streaming, the append, the last chunk flags. Let the server send artifact incrementally. Speaking of streaming, when you call send streaming message instead of a send message, the server opens SSE, server sent event, connection, and pushes the task status update event and task artifact update event. Each event carries the full task ID plus the updated status or artifact. When the status has a final set to true, the stream closes. This is how you get real-time token streaming from any A2A agent. Here are the core JSON-RPC method: send message and send streaming message for task creation, get task, list task for querying, cancel task for cancellation, subscribe to task for push notification. And then the push notification methods such as set task push notification, get task push notification, plus some other runtime capability discoveries. One important detail that all JSON-RPC method is the Pascal case. Send message, not the task/send. The server handles the single HTTP endpoint, typically at the root path. Let me show you the full interaction sequence. A client first fetches the agent card via the GET, then the send message with the JSON-RPC request. The server returns task in initial state, process it, and returns the update. For streaming, the same sequence use send streaming message. The server responds with SSE stream, each event in JSON line with task update. The last event has final set to true. Extensions are how A2A stay forward compatible. Any new capability, custom org flows, multi-turn workflows, domain-specific metadata can ship as an extension without changing the core specs. Extensions are declared in agent card capability sections. The client check for supported extension before using them. This pattern keeps the core protocol stable while allowing the ecosystem innovation. Thanks for watching this lesson on the LocalM Tuts. In the next session, we will set up the development environment, Python, A2A SDK, GitHub models, Azure AI Foundry, and the course repository. You can find in the next video in the A2A protocol course and playlist is there. See you there.